At TRI, we're developing several new capabilities that we believe will lead robots to assist and empower people in their homes. And more importantly, it'll allow older generations to age in place longer and with dignity. Previously, we demonstrated our advances in manipulation capabilities. In particular, we showed our simulation tools and how those tools can give us the robustness that we need for a robot to do a specific task, like loading a dishwasher. In addition to enabling simulation capabilities, we're also developing mobile manipulation that allows the robot to move about the home and learn a wide variety of tasks from a human teacher.
Which object shall I put away?
Cup. Performing tasks in homes is extremely challenging for robots. Each home is unique, with a large number of objects arranged in different configurations. We demonstrate the effectiveness of our approach by presenting results for a variety of tasks under different environmental conditions in our lab and in real homes. So, rather than try to program a robot to do a specific set of tasks, like an assembly line robot, our robot can learn new skills from a human teacher. We teach the robot in VR, or virtual reality. The teacher can see a model of the robot as well as the live data from the robot itself. And it uses that information to teach behaviors that are linked to things in the environment. And that's important because rather than teach the robot a set of direct motions to a very specific instance of the environment, we teach the robot parameters. That's part of a set of safe behaviors, and that's robust to a changing environment. For example, we can teach the robot how to open a refrigerator. We show the robot where to place its gripper, how to hook the handle, and also how hard to push. We can teach the robot about what objects in the scene are important, or what parts of an object are important, whether the object is a bottle or the refrigerator handle. Whichever the object is, wherever the object is, we can teach the robot how to handle it. We can also teach the robot about uneven surfaces in the home, those that it can drive over and those that it cannot. And we can teach it these things with just a very few examples. And once one robot learns that skill, it can pass that skill on to other robots. We call this fleet learning. Like simulation, we believe that teaching is a key capability that will enable robots to be useful in homes.
We designed and built this robot with this type of teaching specifically in mind. It has many redundant degrees of freedom. It can move its body around like a person within a very large workspace. It automatically configures its posture to perform the behaviors being specified by the human in VR. Our robot has high-resolution visual and depth sensors with a very wide field of view. We leverage machine learning techniques to enable the robot to learn from a single demonstration. In this case, more is not necessarily better. The robot is trained to recognize simple audio commands and associate those with behaviors.
Where shall I put the object?
Cabinet. When the robot is taught a behavior, it associates that movement with what it sees in the scene before it. It then combines visual and depth data into a 3D representation of the environment. It then plans collision-free motion for its body and arms. If it detects something unexpected, it can stop, react, and recover, and then plan again. The robot can link actions to visual cues, which also applies to how it navigates the environment. The robot does not need to build a global map of the home, but rather it can navigate like a person. It chooses what action to take based on its visual memory of what it has learned. It's important to remember that our robots are research prototypes, not product concepts. We choose tasks for the robot that we believe motivate the right algorithm development. While the robot must currently be taught every behavior for a specific situation, we're working to generalize beyond individually taught tasks. Ultimately, as one robot learns a task in a home, all robots benefit collectively. Rather than focus on developing robots that replace human activity, we think it's better to focus on robots that amplify, empower, and assist human performance. Home robots are an important part of the solution to help an aging population live longer in their homes and to improve quality of life for everyone. At TRI, we are inventing and improving the key